Okay, a couple more examples here. And I've got these all worked out, so I'm just going to talk through it. Let's see. Okay, so we want a Taylor Maclaurin polynomial to approximate this cosine of 0.1. So we're assuming the center of expansion is 0 because that's the closest integer to 0.1. Don't have to use an integer to expand, but they said Maclaurin, so we're using a 0. In general, you can expand about any point, but Maclaurin tells you to expand about 0. So first thing is I calculate my derivatives of the cosine up to 6. Calculate the values at 0. And then I use those to expand. And notice when I create these coefficients, I have to use those factorials in the denominators of each one. Okay, so that's what I have to add into, in addition to using these numbers here. So this is f of 0. This is f prime of 1 over 1. This is f double prime of 1, which was a negative 1, and so forth. That reduces to this. And then to actually make the approximation, I calculate using my polynomial, cosine of 0.1, plugged in here. So this is approximate. Okay, it's approximate. Now the next problem, they ask us to find a 5th degree Maclaurin polynomial for e to the negative x. So again, first step is find your derivatives. And notice they're alternating in sign, and then calculate the derivatives at 0. Your expansion point is 0. So that's your center. Calculate those, I get these numbers, then come over and start putting them into as coefficients for these powers of x. So this is f of 0, which is a 1. This is f prime of 0 over 1 factorial. This is f prime of 0 over f double prime of 0 over 2 factorial. F triple prime of 0 over 3 factorial. 4th derivative at 0 over 4 factorial. 5th derivative at 0 over 5 factorial. And notice the appropriate powers of x in each case. And that's it. That's the 5th degree Maclaurin polynomial.